In this series of videos, we're going to talk about single slit diffraction. So briefly, let's do a little bit of an overview before we jump into the analysis, because the analysis of this is actually more complicated than the previous two phenomena that we've studied. So briefly, single slit diffraction, the easy part is realizing that that means that there is one slit. And just like before, we want to think of this as very thin, very narrow. Now, what we get here is a different pattern of bright and dark fringes than what we've seen before. There is an area that is the central maximum. It's very wide and pretty bright. And then we get secondary maxima off to the side, and notice that they seem to be less intense and certainly not as wide. So mathematically, this is more difficult to deal with. We can't talk about it. It actually works for a different reason than single slit interference did. So the analysis is a little more involved. But before we jump into that, I would like to clarify the terminology a little bit. And the book tries to discuss this, and I'm not going to necessarily be too picky about how you use the terminology, but there's how we are defining the words, and then there's how they're historically used. So notice that we've seen the word interference and diffraction in a few different contexts at this point. We've talked about the interference fringes that have come up from wave phenomena. We have seen double slit interference being the first thing we studied in this chapter. We then met diffraction gratings, and now we're talking about single slit diffraction. So I want to give you a definition for these two words, not a technical definition as much as a working understanding, and then we'll try to see what of these it connects to. So interference is going to be a superposition of different waves, right? We already talked about constructive and destructive interference, and we always talk about how two waves or more are adding together. So that's interference. Now, diffraction is more of an effect where waves spread out, and that can actually look like going around a corner. So for instance, if there's an open door and I have music playing in the room, the music can actually come out the door and go down the hallway a little bit. And different frequencies of music, higher versus lower sounds, will actually do that differently. And really, this is to contrast it with shadows, right? So shadows are basically, you get a specific shape from your aperture and you're done. That is not what is happening here, and that's because shadows were the ray model and diffraction is our wave model. So diffraction is really important because that is fundamentally going to be an effect of the wave model of light. And it also occurs with, for instance, things like sound. Now, diffraction so far is going to be connected to single slit diffraction. There is going to be an effect here that is very much diffraction. But when we talked about diffraction gratings, we were actually talking about interference. They're called diffraction gratings from a historical point of view, but really what they're giving you is interference. When we talk about diffraction as a phenomena, that has nothing to do with diffraction gratings. Single slit interference is very much an interference phenomena. Now, if you call it double slit interference, there you go, double slit interference, it's in the name. If you call it double slit diffraction, that's not really what's happening. Again, it's not a diffraction phenomena. When we talk about interference fringes, we're usually talking about interference. Now, what's interesting is that when we talk about single slit diffraction, it would help if I spelled it right, when we talk about single slit diffraction, there's actually also an interference component. So diffraction is something that is interesting and relevant. When we talk about circular aperture diffraction, that is very much diffraction, but they're both components of interference and diffraction in it. So I realize that might not have made things very clear, but I do want to pull out specifically the notion that interference and diffraction are not fully interchangeable, but historically it seems like they were. So that's why if I talk about these things, I mean different things that sometimes conflict with how we use it for other terms.